Significant figures are commonly known as those annoying numbers that are so important that they have to stay. You're probably thinking one of two things. Number one, why is this opening slide just a blank slide with black bold words on it? Or number two, oh crap, I have no idea what significant figures are. Well, follow along if you want to continue on this learning adventure. Or just never understand significant figures and maybe just give up on life while you're at it. Let's get down to the basics. What are significant figures? Well, they're meaningful digits in a measured or calculated quantity. The last digit in the quantity can be considered the uncertain digit. We see significant figures in every measurement, calculation, or estimation. Significant figures are important because not every quantity is an integer or a clean decimal. In any situation, it's important to know the details first. So, when we measure, let's say how much volume a liquid has in a beaker or a container of some sort, the amount of significant figures are based off of the range of the measurement. To obtain a measurement from any container or beaker, we must know that a meniscus is the curve in the upper surface of a liquid at eye level, close to the surface of the container or another object, caused by surface tension. Let's take a look at a few examples. In the image depicted to the right is a 5 milliliter graduated cylinder. Since this is 5 milliliters in units, the ones and the tens place are the only certain significant figures. After your last certain sig fig comes your estimated significant figure. Visibly, the liquid surpasses the 2.5 mark, so we know it will be more than 2.5 milliliters. It then surpasses the 2.6 milliliter mark. Therefore, the number next to the 0.6 is your estimate. The meniscus is in the middle of 2.6 and 2.7. Therefore, the volume of this liquid is 2.65 milliliters, with 3 sig figs being 2, 6, and 5, your estimate. Here we can see that the meniscus is more than 20.0 milliliters and less than 25.0 milliliters. Therefore, it will be somewhere in between those two measurements, and since the graduated cylinder has a unit marking every 1 milliliter, we estimate the tens place, the number after the decimal place. So, since the meniscus is right on the unit marking, the volume of this liquid is 24.0 milliliters, with your 3 significant figures being 2, 4, and 0. Moving on to sig figs and given measurements. Let's say that your teacher or professor wants you to find the number of sig figs in a given measurement. Easy, right? Well, there are rules. Number 1, non-zeros are always going to be significant. Number 2, zeros between non-zeros are also significant. Number 3, trailing zeros are only significant if the number contains a decimal point. And number 4, leading zeros are never significant. With what you know now, it is only best that you test out your knowledge. Check out the practice problems, and if you're having a hard time understanding why the answer is the answer, review back to the sig fig rules. Since we know that the significant figures are in every number or quantity that we observe, there are rules for adding and subtracting these quantities together. Number 1, your final answer after addition or subtraction should have as many decimal places as the least accurate number. Number 2, round your answer to the correct number of sig figs based off of the lowest sig fig number in which you are calculating. The rules for multiplication and division are easier to understand than those of the addition and subtraction rules. Rule number 1, the answer has the same amount of sig figs as the value with the lowest sig figs. For the multiplication example, since 24.0 centimeters has the lowest amount of sig figs, your final answer will have only 3 sig figs as well. It's the same rule for division. So for the division example, the amount 3.3 centimeters has the lowest amount of sig figs in the problem. your answer will have only 2 sig figs as well.